Welcome to the Anamena video tutorial Unit 4.5 Photogrammetric Evaluation using the AICON DPA Pro software. My name is Christoph Prahl. I have been working for 5 years at DLR in the CSP field of optical measurement of concentrator shape and collector development. The content of this unit is how to use the software AICON DPA Pro to obtain 3D coordinates from images. We will first talk about the requirements. This is mainly the installation and the license for the software AICON DPA Pro, and we also need data for so-called templates which contain information mainly about the camera and the reference cross. Then we will be guided by a step-by-step evaluation. The main steps are how to open a new project, how to start a new measurement, the creation of the template which fits the hardware we have used during the image acquisition, then how to start the measurement itself and the evaluation. Finally, we will learn how to interpret the results and also how to check the accuracy of the obtained 3D coordinates. The main requirements is that we have a license for our software. The AICON 3D Studio is hard lock protected with a dongle, so we cannot use the software without a dongle. Then we need a template. The template contains mainly the information about the camera, which is the size of the CCD, the number of pixels, and the focal length of the camera. In addition, it's also possible that the template contains information about the distortion parameters of the camera. Then, the reference object is also part of the template. The reference object are the 3D coordinates of the 5 coded targets on the reference cross. These coordinates must be known with high accuracy because they are needed for the pre-orientation during the evaluation procedure. When we have finished the image acquisition and we want to start with the evaluation, which means to obtain the 3D coordinates from the images, we must start a new project. When the hard lock dongle is valid and connected to the computer, we can double-click the AICON 3D Studio icon on the desktop and we will see a new project screen, as we see here on the right. If we want to add a DPA measurement, we need to click Edit, Insert and insert a new DPA measurement. There's also the possibility to load object points, to do an online measurement or to load reference data. It is very important to define a proper name for the project. In this particular example, the project is called Anamena Capacity Building Course 1 Test. But if you do a measurement of a CSP collector, it should contain the date and the type of object, for example. Then you click OK, and the project and the folder structure of the project will be automatically created. The next step is the creation of a template, which contains the camera and reference cross information. If there is no template available, then you have to select a new template and click Next. If you have been using the AICON 3D Studio software before, there is already at least one template available on your computer, which represents the used camera system. If one of the template represents the camera and reference cross you have been using for the current evaluation, it can be reused and the template creation can be skipped. If you create a new template, firstly you have to select the camera. There is a new camera icon and then the following window will appear. It is possible to enter the resolution, sensor size and focal length, or you can use a camera from the drop-down list. It is then possible to edit these parameters, or it is recommended to import camera parameters from a file of a previous measurement. This file contains the exact parameters of the CCD size, the focal length, and it already contains very good starting values for the distortion parameters. You can select such a file, which has in general the extending IOR. These files can be stored on your computer under the following path. You click Open and then OK, and then you will see a window which contains the main camera parameters, the pixel size, the size of the CCD in millimeters, the exact focal length, and these parameters describe the distortion of the lens. When you have finished the camera selection, you can click Next to enter the selection of the reference system. Click New Reference Object icon to open a new reference object. If there are already reference objects available in the drop-down list, select the one you have used in the current measurement. You can also load a reference object either from the current project or from a file stored on your computer. For example, click Coordinate File and you will be asked to select the reference system with the file extension OBC. These files are also stored on your computer under C AICON User Data. Click Open. You are then asked to check the import unit, which should be millimeter. You can select all points or only a fraction of them, and you can cross-check the data using the 3D view. You can then edit the name of the reference object and save it under a different name. Apart from the camera information and the reference object, you can add additional information to the template. This is, for example, scales, which could be the scale bars you have used in your measurement. You can also add fixed reference points, which have been obtained, for example, with a tachymeter, but these parameters are optional. If you don't want to add these parameters, please click Next. The template contains also information of the coded target used. There are different types of coded targets, 12, 14 or 20-bit. They can be black on white background or white on black ground or both of that. Please select the values here according to the coded targets used in your measurement. You should disable the checkbox Automatic Adapter Correction after measurement if you have not used adapters. The next window will show the option to edit the expert settings. These settings have mainly an influence on the measurement of the images, so how the coordinates of the targets within the images are estimated. You should not edit the expert setting unless you know precisely about the consequences. You can deactivate the expert settings in the main window by Options Automatic Measurement Activate Expert Settings. For the parameters which have an influence on the image measurement, it is recommended to reset them to the default values. Then click Next. If you have activated the checkbox Automatic Adapter Correction, this window appears. If you have no adapters available, click Next. You have now finished the creation of the template. A window appears which allows you to cross-check all the input data. This is the camera, the reference information, and the type of coded targets. If you agree, click Finish. You are then asked to assign a name to the created template. It is very important that the template name consists the type of camera, the reference object, the date of measurement, and the purpose of the measurement. This is very important that the template name contains all that information because the template cannot be reviewed or edited. Now you can select the template again and click Next. You have now opened a project, opened a new DPA measurement, created or selected a template, so you must now enter the name of the measurement, which means that one project can contain different measurements with different templates. The measurement name should again contain important information about the measurement, for example the object, the date or further information. You then should enable the checkbox Start Automatically Image Selection and Measurement and click Next. There will appear two windows which again show the expert settings and a summary of all parameters. These are the same windows that have been shown to you after the creation of the template. These windows can be skipped. You are now asked to select the images of your object. Click on the button Select Images and you are asked to give the path to a folder containing the images of your project. Different types of image files can be loaded, for example Kodak format, text file image or JPEG. In most cases, the camera stores the images as JPEG. If you have chosen the destination folder, click Choose All Images within the destination folder if you want to use all of them, but you can also select only a part of the files. A window appears which shows you the exact names of all image files. If you agree, click OK. If the files are stored only on the memory card of the camera, it's also possible to create a local copy of the images in the project directory. We recommend this option. Then the automatic evaluation starts, which means that the AICON DPA Pro will load the images, look for coded and non-coded targets in the images, and then calculate the 3D coordinates of all targets from this data. Depending on the size of the object, the number of targets and the number of images, this evaluation can take from a few seconds up to several minutes or half an hour if you have a very large object. So have a coffee and wait. When the automatic evaluation has finished, the following screen should appear. In this screen, you see the statistics of the adjustment, which gives an estimation of the measurement accuracy, and you also have the X, Y, Z coordinates and the estimated uncertainty for all points which have been highlighted. If such a screen does not appear and an error message occurs, we recommend to check the AICON manual from page 531 and the following pages. How do I interpret now whether the results returned by the AICON software are good? You have to check whether all points of interest have been actually measured and if they are measured with sufficient accuracy. The final window of the evaluation screen offers also a 3D view where you can check whether all points of interest have been measured. The number of rays, which means the images in which a certain target has been found, should be more than 10. The uncertainties in the different directions should be lower than 0.1 millimeter. The RMS value of the uncertainty should be more or less equal to the median value of the uncertainties, and the sigma 0, a statistical value which gives the quality of the total evaluation, should be lower than the shown value. If all this is fulfilled, your measurement accuracy should be okay. There's also the possibility for an external cross-check of the accuracy using the calibration rods which you have put to your object. If you want to do an external accuracy analysis, you can export the object coordinates as shown on the right, which means click Edit, click Export, click 3D points. An external accuracy analysis using the points on the calibration rods could do the following. You could or should compare the distances of the points on the calibration rods measured by the photogrammetry and compare these distances to the distances of the same points as stored in the calibration file. If you had a perfect measurement, the differences between those two distances would be 0, but due to measurement uncertainties, there are smaller or larger deviations. The graphic on the lower right shows the distances for different points together with the mean and maximum value. So for the particular measurement shown here, the maximum deviation is in the range of 0.2 millimeter, so the overall measurement accuracy should be better than this value. You need an external macro programmed in a numerical software to obtain these deviations from the 3D data delivered by the AICON software.